Hi, so the first thing I want to talk about today is really just give a little bit of a primer on connectivity. Um, and so, when we talk about data, one of the things we need to understand is where's all this data coming from? How are we getting it in such a common way that we can leverage it rapidly and take advantage of it? And so, the first thing I'm going to go through is some low level stuff. Um, about how do you actually get to the internet, which is one of the key, underlying technologies that have enabled this whole push to data. So let's talk about networks. There's a lot of information on these, and I'll let you kind of read through these charts. But basically, what we're going to talk about is over a period of time, and this is really over the last 40 years. How you've gotten to the point where you can automatically turn on your phone and it hooks up to devices, printers, and all this other stuff automatically. There's a lot of layers of technology that underpin that. First, we start basically with a wire. Before we went to wireless, you started with a wire. There's a current on that wire, on and off, that gets us to binary. Um, when it's on, you're zero. When it's on, you're one, and when it's off, you're zero. Um, and then there's things like Morse code. That's okay. You can send it off and on and send that tap and do it over patterns. But what they really want to be able to do is move more information at a time. So you get to the idea of a bus, right? Where you've got 8 wires all synchronized on, off. And then depending on what you have on each wire, whether it's on or off, that gives you basically a byte of information. As the computer starts to send its clock, if you're familiar with operating systems, the clock will say, hey, every nanosecond or whatever, we're sending out, I'm going to turn on and turn off, and that's going to be a charge going to go across, and whoever's listening on that clock knows to check, to check, to check, to check. And so each time you get 8 bits at a time. And that's how you communicate within a computer. Essentially, that gives you an ASCII standard, by the way. 8 bits give you an ASCII standard. Each one of those is a letter. I've got some examples there, but those series of 8s and zeros represent something in ASCII standard. You build those up, you can send a message, right, that we would be able to read. Fine, okay, so that's point to point, that's within a computer. But you can't have wires across every machine in the world, right? You can't run a wire from your machine to every other machine that you could possibly. So you create the idea of addresses. So that gets us to the Internet Protocol, IP addresses. You've got subnets, you've got nets, and you've got every machine has a particular unique address. That becomes IP protocol. Now, what you need to do then is packet those characters into envelopes and put them on the wire with those addresses tied to them. So just like you're mailing something, you get something across the wire, and the first thing you expect to read is an IP address, and the second thing is going to be the message, and then there'll be some break. Now you're getting into transmission control protocol, TCP. So TCP IP is the underlying network protocol that we have. So like a telephone switchboard or mail depot, you're going to use hub and spoke switches located everywhere to sort of route all these messages that are going everywhere. Now each machine needs to be able to interpret the data and the packets that are coming through. It needs to be able to strip out packets and interpret it individually. So now let's add some complexity. We don't want to send just packets with packet of information. You want to send files. They're going to be huge, right? You can't send them all because it could break up. It could be a lot of things could happen to it. So you need to be able to interpret file delimiters from that packet. It means you're going to have an end of file character associated with something, and then as these packets come through and if they're addressed, they're just going to continue to build on your side of the machine. And then you get these networking programs then on the computer that can do all that processing for you. Networking functions simply spit out files for our applications to be used. They load in all the packets, they listen to what the packets are telling them to do with that information, and if it says to make a file, that's what it puts on your machine as a file. HTML, when you download a web page, that's all that is. It's listened to an HTML delimited file, and it presents it for you into your browser because it knows that when it comes in, it goes on port 8080, it's going to go into a browser program that you have running and present that file. So now you no longer, as long as everyone's using these standards, you no longer need to care about all those internals that are going on, right? Now you can just use the network. So what's the whole picture? There's basically a 7-layer stack that we operate on. Bottom layer down here is the physical layer. All right, then there's a data link layer, a network layer, a transport layer, a session layer, a presentation layer. I've got the descriptions over on the right side there. But basically, you've got a set of programs in every computer that manages each one of those layers to certain standards. Physical layer is electronic signals. Data link layer transmits those packets like we talked about using IP. Network layer routes them to different addresses based on lands and WANs. Transport layer ensures the delivery, so now you're getting a transmission control. Session layer says, hey, maybe I've got something, I'm going to hold this session and maintain this connection over time. It maintains order. Presentation layer, then now we're getting to ASCII and the representation of all those data into something. And the application layer then is whatever's going to be the final thing, right? Your browser, what have you. All of those are standardized. So the network layer, here we talk about IPv4. This was what has been historically what we use for the network layer. Nowadays, we're moving everything to IPv6, which is a much larger set of numbers to use. The reason, because IPv4 was essentially running out of addresses. As we started to go to Internet of Things, which means that all your phones, all your devices, your refrigerators, everything has an IP address that we're connecting to over wireless, we're rapidly running out of addresses. IPv6 pushes that number of addresses in a huge way. So we've been transferring our technology to go over to IPv6 over a period of time. Number of addresses will probably never be filled in IPv6. Physical layer is then the next step up. So now we got things like, what are we talking about in the physical layer? You're talking about broadband, right? Being able to get internet over your cable system, getting it over DSL. Those are the kinds of things that you're talking about with the physical layer. Wireless connectivity, so radios in your phone that can listen and then interpret the bits that are coming in. 2G was great for voice. 3G got us satellite comms and comm towers, voice and data. 4G standards enable faster data rates, digital IP network, and broadband internet connectivity over your phone. Now we're moving into 5G. 5G will expand 4G immeasurably to the point where we can actually use the Internet of Things with cell phone technologies. Wi-Fi is another one that's sort of a standard for short-range IP comms. So you have Wi-Fi routers in small places, 802.11.b, therefore how you communicate within a small WAN. Near field is for secure shortwave radios, and then Bluetooth for small devices, much smaller distance, and not a rapid communication there. All of them are sort of geared. All this technology is geared to accomplish a certain thing, but the technology within your systems then will integrate all of those through the other layers of the protocol, so that you can communicate in total from your headphone to your wireless headphones to your phone to your ISP out there into whatever you're pulling music down from out in the cloud. All that interconnectivity and standards drive that communication. Internet of Things then is basically what we're moving to. So think about everything I said about the refrigerators. This is the same kind of thing. The data is available to make better decisions from every source that we have connected into the Internet of Things. There's an immediacy to the data, there's a speed of processing associated with it, and there's AI to speed all these decisions. When you're getting data from robotics, from UAVs, from your televisions, speakers located in people's homes, from security systems, all this stuff is creating information, right? It's automatically sending it to various places. That means a huge amount of data is available for us to start thinking about how are people actually using our products? How are people actually communicating, and how are they going about their lives? What are their patterns of behavior that we can learn from and then develop greater products and systems to accommodate? And from the IT perspective, that means that we have to be able to support that data going into our business so the business can make better strategic decisions, and also organically within the IT department. That means we have to be able to take advantage of these things ourselves, because our employees are going to be using these capabilities. Our security systems will be using these capabilities. And how do we measure all that data in ways that will make us more productive and more efficient, and then also provide our business the means to measure that data from our customers so they can make and develop better products? This all leads to e-commerce, right? So electronic commerce is what you used to call it. It's now just basically commerce. It's become so prevalent in how we do things that it barely even earns a separate connotation here. But basically, when you hear the terms B2C, B2B, what they're talking about is direct to consumer, all right, where everyone's going in through websites, everyone's going through sale fronts, everyone is being able to reach directly to the customer and understand their behavior, respond to the behavior, and deliver directly to that customer. That is the panacea of businesses, right? They don't want to have to go through middlemen. They don't want to have to go through warehousing. They don't have to want to go through distributors. All of that stuff takes margin. All of that stuff takes cost. If we can, the more you can get direct to consumer, the better go. All the internet and Internet of Things enables that. All the standards that we built up over the years through this 7-layer protocol have enabled the point now where I can on a device basically go to any company and get something sent to me, right, and delivered direct to my doorstep within a matter of days. B2B was the first step in that. That was business to business. And what they look at there, which you're going to be very concerned about within your IT departments, is automated transactions, contracts, service layer agreements, where when you standardize how you do your business relationship with another company, and you have that service layer agreement, service level agreement with them, then all of a sudden you can codify, not just in contracts, but in the actual implementation of connectivity between you and another business, the rapid transfer of supplies, the rapid transfer of material that you're going to need for your business. Network in the payment schemes for all that stuff. Instead of having groups of people doing contracts, groups of people writing checks and all this can be done electronically now. Network technologies allow for that ordering and payment. E-sourcing allows for the RFQ process to go through. It streamlines them and controls all the costs associated with that. Electronic exchanges then are the result of that. They get set up both vertically, in which one industry is going to basically set up suppliers up and down the chain for a product, and horizontal, where you supply multiple industries with a different type of product or with the same type of product. Office supplies, for example. You're going to have electronic exchanges where a bunch of people can come in and buy stuff from you, or vertical exchanges where you've got basically your suppliers are supplying you with everything you need, except you're fanning out and having those exchanges so you can get the best price possible. Mobile commerce then is the other aspect of this. So QR codes that you're familiar with at restaurants, mobile check-in, mobile purchase, location-based marketing, all of this stuff is about the analytics process that you can use to learn from your customer and to develop that relationship, both from a business to consumer, from a business to business standpoint, and to make sure those electronic exchanges are as fast as possible, as efficient as possible, and can maximize the revenue for your business and make sure you're maximizing the margin. As the global business continues to introduce competitive pressures, the ability to utilize this technology and all these standards we've built on over the last 20 years to reduce your cost makes you more competitive and gives your business an opportunity to succeed.